Hello again and welcome to another RouTube video. In today's video I will be covering how to determine the equation of a straight line in multiple scenarios. Students will begin to learn about this in Year 8 and continue developing their knowledge in Year 9 and beyond. So 4 learning objectives in the video. The first one is to determine the equation of a straight line given the gradient and the y-intercept. The second objective is to determine the equation of a straight line when given the gradient and 1 point. The third objective is to determine the equation of a straight line when you're given 2 points. And the final objective for this video is to determine the equation of a straight line from a linear graph. Okay, so let's begin by determining the equation of a line when given the gradient and the y-intercept. Now, if you're all okay with the gradient and the y-intercept, this shouldn't be too difficult for you. But some of the next parts of the video might be a little bit more challenging. But this part here should be fairly straightforward if you've been introduced to the gradient and the y-intercept before. So determine the equation of the line with a gradient of -2 and a y-intercept of 3 or +3. Okay, now in this example, all our knowledge should come from the equation y equals mx plus c, where m is our gradient and c is our y-intercept. Everything always starts with y equals mx plus c. So therefore what we can do, we can just use that rule and then substitute the values that were given in the question into that rule. So we've now got y equals, now instead of m, we're going to go to the question and see what did they tell us that the gradient was. Well, the gradient was -2, so therefore it's going to be -2x. And then the y-intercept is going to be +3, so therefore we have our c value as +3. So there's our equation when we are given the gradient and the y-intercept. Y equals -2x plus 3. All right, let's turn our attention to determining the equation of a line from the gradient and a single point. So now we're still been given the gradient, but now we haven't been given the y-intercept. We've just been given a single point on our linear graph. So determine the equation of a straight line that goes through the point 1 and -3 if its gradient is +2. Okay, so let's write down what we know. So we know that the point that it goes through is 1 and -3. And we also know that m equals +2. Now, once again, all our knowledge must come from y equals mx plus c, where once again, m is our gradient and c is our y-intercept. Well, now we can't do what we did previously because we don't actually know the value of our y-intercept. We don't know the value of c. But what we do know, we actually know the value of x, we know the value of y, and we know the value of m. So we can substitute the value of x, the value of y, and the value of m into y equals mx plus c, and then solve to find c. So now we're going to rewrite our equation. Instead of writing y equals, we're now going to take the y value, which is -3, and m is +2. I'm going to multiply it by the x value, which is +1, and we're going to add c. Now we can just solve the equation to find the value of c. So now we keep moving down and we say -3 equals, now we've got 2 times 1, which is 2, and then 2 plus c. Now we need to isolate c to get it on its own, so we're going to use our inverse operations. So now we're going to subtract 2 because 2 is currently being added to c, which is then going to cancel out the positive and the -2 on the right-hand side of the equation, which then leaves us with -3 minus 2 should be -5 on the left. And then on the right, we're just left with c. So now we have the value of c, which is our y-intercept. We have the value of m, which is our gradient. We can now determine the equation. It's going to be y equals, now our m value is 2 and our c value is now -5. 5. So this is the equation of that line. So you can see there's an extra step or two when you're given a point and the gradient rather than just being given the gradient and the y-intercept. So the equation of the line that goes through that point with a gradient of 2 is y equals 2x minus 5. All right, now let's determine the rule of a line from 2 points. So now we've been given 2 points, we need to sort of follow a different process to then find the equation of the line. So if 2 points on a straight line are known, then the gradient, which we know is m, can be calculated by using the formula m equals y2 minus y1 over x2 minus x1. All right, and we'll get into that in a second. But that's the formula you need when you are given 2 points. So the question says, determine the equation of a straight line passing through the points negative 6 and 11 and 6 and 23. So they are the coordinates of, or their coordinates on the line. Okay, we just need to work out what the equation of that line is. So we see that formula m equals y2 minus y1 over x2 minus x1. So that's going to give us the gradient. Okay, so that formula there is going to give us the gradient, which is why we see it as m equals. So what we need to do with our coordinate points, okay, we need to give them labels. Okay, so x always comes before y. So therefore, in this case, x1 is going to be, or negative 6 is going to be x1, which therefore makes 11 as our y1 value. And then 6 becomes our second x value, hence it becomes x2. And then 23 is our second y value, which then becomes y2. Once we have done that, then we can use the formula and substitute the values into the formula to find the gradient. So let's do that. Now we've got m equals. Now y2 should be, we'll fix this up, it should be y2 is 23. And then we're going to subtract y1, which is 11. And we're going to put that all over x2, which is 6. And we're going to subtract negative 6. Now, if you need to use a calculator, please do so. The top of the fraction is going to be 12. 23 minus 11 gives us 12. And the bottom of the fraction, 6 minus negative 6, that sign's just going to be 6. And then the subtraction and negative sign just becomes a positive. So it's going to become 6 plus 6, which becomes 12. So therefore, our gradient is 12 over 12, which is just 1. So our gradient is 1. Now we can use the previous example as a bit of a guide. So now we've been given the gradient and we have 1 point. And we should know how to find the straight line, the equation of the straight line once we have the gradient and 1 point, because that's what we did previously. So now what we're going to do, once we have the gradient, we can pick either point. We can pick this point or this point. My recommendation is to always pick the point that does not contain the negatives. If they both contain the negatives, well, you've got to. But if there's 1 point that does not contain negative numbers, go against it. That's my recommendation. If you do, you should still get the same answer, but I know it sometimes gets confusing with the negative numbers, so go with the positives if you have 1 point that's all positives. So what we're going to do now, we're going to follow the same steps we followed in the previous example. So now everything comes from y equals mx plus c. Now we're going to use, I'll write the point up here, we're going to use point 6 and 23. And we know that m is equal to 1 because that's what we just calculated. Now 6 is our x value and 23 is our y value. So then in the formula y equals mx plus c, we're going to replace or substitute the x, the y, and the m, and then solve to find c, just like we did previously. I might change color. Let's go to green. So we've now got, instead of y, it's now going to be 23. Instead of m, it's now going to be 1. And the 1 is multiplying by x, which is 6. And then we're going to add our c. Now what we can do is solve like we did previously. So we've now got 23 equals 1 times 6, which is 6, 6 plus c. Now you'll see there's only one thing happening to c, and 6 is being added to it. So we're going to use the inverse operations, which is to subtract 6, which then cancels out the positive 6 and the negative 6 on the right hand side. So then on the left hand side, we're left with 23 minus 6 gives us 17. So 17 equals c, which is the same as c equals 17. So we've now got our m, our gradient, and we've now got our y-intercept. We should be able to find our equation. We've now got y equals m, which is 1, x, and c is positive, so therefore it's positive 17. And in algebra, we know we don't need to put the coefficient of 1, so we can rewrite that as y equals x plus 17. And there we have found the equation of the straight line when we are given 2 points. Okay, and the final part for this video is to determine the rule of a line from its linear graph. So determine the equation of a linear graph shown below. So if we're given a linear graph, we're given the coordinates, or even if we're not given the coordinates, we should be able to find the coordinates of the 2 points. Remember, all we need is 2 points to be able to find or determine the equation. The process is as follows. So we should hopefully be able to identify where the y-intercept is straight away. Remember, the definition of the y-intercept is the moment or the time in which the line cuts through or hits the y-axis. Okay, so we should already know that the value of c is positive 4. Because remember, I'll say it again, the y-intercept is the moment that the line cuts through or hits the y-axis, okay, which is positive 4. Now to find the gradient, okay, remember the gradient is rise over run. I haven't spoken too much about rise over run today, but hopefully you've got some knowledge on rise over run. So you essentially need to start at any point and rise and run to the next point. So what we're going to do, doesn't matter where you start, which point you start at, as long as you rise before you run. So we're going to start at that point there, which is 2 and 0. And we're going to rise and run to the y-intercept. So we are going to rise up. We're going once, twice, 3 times, and 4 times. Okay, so to work out our m, it's going to be rise over, let me start that again. To work out our m, it's going to be rise over run. So essentially what we need to do is, from that original point that we started at, 2 and 0, how many places did we go up? Well, we can just count them. We went once, twice, 3 times, 4 times. So our rise is going to be 4, and it's going to be positive because we went up. If we went down, it would be negative 4. Now, from that point where we stopped, how many places do we need to go to the left? We need to go once and twice, which I'll do in a black pen again. We're going to go once and twice. But because we went to the left, our values, we're going from positive 2 to 0. So our values are decreasing. So when we move to the left, when we run to the left, our run's going to be negative. Just like when we rise down. If you rise down or run left, it's going to be negative. So then now our m is equal to 4 divided by negative 2. Hopefully you can identify that should be negative 2. So now we've got our c, we've got our m. Once again, we start from y equals mx plus c. And we know that our m value is negative 2. We just worked it out. And our y-intercept is a positive value, and it's 4. So therefore, the equation is y equals negative 2x plus 4. Thanks again for watching another video brought to you by RouTube. Hopefully you learned a thing or two about the gradient, the y-intercept, and finding the equation in multiple scenarios. If you did learn a thing or two, please feel free to like the video and subscribe to my channel. I will continue to upload content, so please keep an eye out on some new videos that will be up shortly. Catch you next time.